Under 3.3 in P1, we are expected to learn how to solve simultaneous equations graphically. And this one is not new to you, as every point on a linear or curve satisfies the equation of that line or curve. The points of intersections of two lines or curves satisfy both equations simultaneously. And of course, the solutions to a pair of simultaneous equations represent the pairs of intersections of their graphs. And to start with, to see this, the keyword is the point of intersections. It'll give you both the value of x and the value of y. Let us look through example 4, which says, on the same axis, draw the graph of 2x plus 3y is equals to 8. 2x plus 3y is equals to 8. And also 3x minus y is equals to 23. And what we need to do is just have, because these are straight lines, you would talk of just 2 points per line. And for this one, let's try to tabulate x and y. When x is, let's say, a negative 2, what is the value of y? Minus 2 times 2 minus 4 plus 3y is equals to 8. That means 3y is equals to 8 plus 4, which is 12, and 12 divided by 3, y becomes a 4. That is just but 1 point. We may talk about some other point. Let's talk about when x is a 4. When x is a 4, then this is 8. 8 plus 3y is equals to 8. So 3y is going to be 8 minus 8, which is 0, and therefore y is 0. Those 2 points are enough to draw that straight line because you will draw and produce the line. That is line 1. What about line 2? We have x and y. When we can talk about x being equals to that 4, let's talk about x being equal to 4. 4 times 3 is 12, and 12 minus y is 23. And you realize that y is 12 minus 23, which is minus 11, negative 11. Let's talk of when x is probably a value like 7 or 6 for that matter. Let's talk about 6. 6 times 3 is 18, minus y is equals to 23. And y is equals to 18 minus 23, which is minus 5. Minus 5. What about 7? What about 7? 7, 21 minus y is equals to 23. So y is equals to 21 minus 23, which is minus 2. That we have taken like 3 points. Probably we can even add that point on the upper graph there. When x is 7, we are having 14. 14 plus 3y is equals to 8. And 3y is equals to 8 minus 14, which is minus 6. And y is equals to minus 2. Minus 2. I want us to just look at that point with a keen eye because it is repeated on both graphs. But let us just have to construct this graph. That way we are having 1, 2, 3, 4, 5, 6, 7, 8, minus 1, minus 2, minus 3, minus 4, 1, 2, 3, 4, 5, 6, 7, and even 8. And let's talk about 1, 2, 3, 4, 5, 6, 7. And minus 1, minus 2, 4, minus 1, minus 2, minus 3, minus 4, minus. Let's talk about when x is minus 2 for the first line, we are talking about 1, 2, 3, 4. So minus 2, 4 there, 4, 0 there, and 7 minus 2 there. So we are kind of going to have a straight line. Please remember to use a ruler there. And for the second one, you can even name this one. This one is going to be 2x plus 3y is equals to 8. Is equals to 8. For the second line, when x is minus 4, negative 11. When x is 6, when x is 4 minus 11, when x is 6 minus 5 there, when x is 7 minus 2, you can see the same point is on both lines. And that means, again using a ruler, you should have such kind of a line and name it. This is 3x minus y is equal to 23. The values of x and y are the coordinates of the point of intersection. So in this case, the solutions of these two simultaneous equations, you'll find that x is equals to the value of x at the point of intersection, which is basically 7, and y is the value of y at the point of intersection, y is equals to negative 2. And that is just like it. Every time you want to solve simultaneous equations graphically, please plot the two graphs in the same set of axes and note the coordinates of the point of intersections. In our case, x is 7 and y is 2. If you want to verify this, then you can substitute any of them in any of the equations. Let's say 2x is 7 plus 3, y is minus 2 is equals to 8. If this is true, then we're going to have 14 minus 6 is equals to 8. And true to it, we have our values of x and y. All right? Kwisha hiyo.